Then, so what we are going to see now, the glomerular filtration. That first aspect we are talking about, the glomerular filtration. Okay, so let me talk about the glomerular filtration. In the glomerular filtration, first of all, I am introducing that this particular set to you, that you need to know the whereabouts of this particular. This is Bowman's capsule, isn't it? This is the Bowman's capsule, and this is Afferent Arteriole, and this is Efferent Arteriole. So that the Afferent Arteriole enters into the neck of Bowman's capsule and form a bunch of capillary network. What do you say? Glomerulars. That is called as glomerulars. Okay. Then you see the diameter difference between the afferent arteriole and efferent arteriole. Afferent arteriole is larger in diameter and efferent arteriole is smaller in diameter, isn't it? So what it makes the diameter difference, what it can create. Let us see what it can create. For example, in a closed bucket, imagine with the help of larger pipe, you are sending water inside the bucket, and with the help of smaller pipe, you are removing water. The larger pipe is sending water and smaller pipe is removing water. So what happens in the bucket? I am talking about in the bucket. And what I said, this is closed bucket. So more water is pumping here, more water we are pumping, and less water is coming out. So what can be expected here in the bucket? So what can be expected? It raises the pressure in the bucket, isn't it? I said this is a closed bucket. With large pipe, I am sending the water, and with small pipe, the water is going out. So what can be expected here? Pressure. So see this. We may have the similar kind of issue in case of this particular nephron. So who is the closed bucket here? This area, glomerulus. That afferent arteriole is larger in diameter. Efferent arteriole is smaller in diameter. So afferent arteriole sending more blood into the glomerulus and less is coming out from the efferent arteriole. So what can be expected in the glomerulus? That can be more pressure can be expected in the glomerulus, isn't it? The glomerulus is having more pressure. Okay, so that what do you say? The glomerular pressure. The pressure, glomerular pressure. Who created that particular pressure? The pressure created by the diameter difference between the afferent arteriole and efferent arteriole in the glomerulus is 60 mm of H. That is 60 mm of H. That particular pressure. So how does the pressure is created? Very important. How does the pressure is created? Diameter difference between the afferent arteriole and efferent arteriole created some pressure here in the glomerulus. So that we say glomerular osmotic pressure is going to be what created is 60 mm of H. Okay. Then now we need to talk about the opposing pressure. Opposing pressure. What is opposing pressure? Any object is going to have such kind of opposing pressure. Any object. That means here, if you are lifting a particular stone, a man is lifting the stone. So when you are lifting opposite to the gravitation force, isn't it? You are lifting opposite to the gravitation force. So that means we are using energy. We are using energy against this particular. For example, to lift this particular, a man is using some 100 ATPs. To lift this particular stone, a man is using 100 ATPs. If we say, so how much energy is using to lift the stone? So try to understand this particular phenomena. A man is using the 100 ATPs to lift the stone and get lifted up. That how much energy is using? What I am saying, how much energy is using to lift the stone? We can't say 100 ATP. Why? Because that imagine that opposing energy, the gravitation force which is pulling the stone is 80 ATPs. That how much energy you used? 100 ATPs. What is the opposing energy? 80 ATPs. 100 minus 80, the net energy is going to be 20 ATPs. 20 ATPs are enough to that to lift that particular stone. Let us take some example here. Anything you can take. Anything opposing energy. Suppose when you are pushing something, when a particular human being is pushing something like this, pushing an object, that object is also having some opposing energy. Means, for example, to push, you are using 100 ATPs of energy. To push that particular object, you are using 100 ATPs of energy. That in that, some 70, 80 ATPs to neutralize that particular opposing pressure only. So that means that object is little sliding. What it means? The above the opposing energy, you are using energy. The total energy is 100 ATPs. Opposing energy of the object is going to be 80 ATPs. Then 100 minus 80. So what is the net ATP? 20. So with that 20 ATP, that object will slide past. Got my point here? That opposing energy for opposing energy or opposing pressure, whatever it may be. So that always is going to be, every object will have some opposing energy. So when you are moving an object and you are lifting an object, what we can understand that we need to equal that opposing energy. More than that, when you are using, that object will be pushed up. So I'll prove this. For example, there is a particular a three-floor building with the help of a 1.5 HP motor. No hurry for us. That very important thing here. Very confusing area. So textbook lines, to understand the textbook sentences, this is very essential for us. Very essential to understand these kind of processes here. That after that, when you are going to answer different kinds of questions, that problem should not be raised over as I am taking time. With the help of 1.5 HP motor, if you are pumping water to the third floor, it will go with some speed, isn't it? It will go with some speed. That means what I am pumping? Water. Then imagine into the same third floor with the same motor, 1.5 HP horsepower motor, if I am pumping blood to the third floor, if I am pumping the blood, can we say that blood also will go with the same speed that we used with the water? The blood also will go with the same speed? Definitely not. That our logic says that blood moves little bit slower. Why? Blood is a colloidal substance. Okay, if you are opposing to use blood, use pulpy orange. So third floor we are pumping pulpy orange. Third floor we are pumping Sprite. So which one will be the faster, Sprite or pulpy orange? Definitely Sprite. That's why, because they are going to say that is very clear. At least pulpy orange is not clear. That having so many the fibrous waste materials can be seen over. Okay, I use the word waste material. Okay, no problem. The waste materials are present. That means they have some opposing energy. So first of all, you need to understand here, every object will have some opposing energy. Then when we are talking about the liquid, we have to use that word called opposing pressure. Blood colloidal opposing pressure is comparatively more than the water opposing pressure. Do you accept this? If you accept, we'll go to our previous topic. What I said here, first of all, we created some pressure. How much pressure you are created in the glomerulus for filtration to push the objects into the particular neck of the Bowman's capsule? How much pressure we are created here? 60 mm of Hg pressure is created. How does the pressure is created? Pressure is created between the diameter difference between the afferent arteriole and efferent arteriole. Diameter difference between the afferent arteriole and efferent arteriole created some pressure. Okay, so this pressure, that afferent arteriole and efferent arteriole is created some pressure here. This particular pressure which we created here. So how does it created? That is very important to be known. Then after, we need to go with the opposing pressure, that particular issue. So I am passing the first statement. I am repeating again, that because this is very important concept here. So what I declared, the two issues at present, till the time I declared the two issues, presence of two issues. One is the diameter difference between the afferent arteriole and efferent arteriole create some pressure. Okay, so what pressure they are going to create? That the particular pressure which is created by them is due to the diameter difference. Now what I am saying, some opposing pressure can be expected. Let me draw the same here. So with that created pressure, what we are doing exactly? This is the afferent arteriole. Now I am drawing little bit glomerulus here. I use another color for the glomerulus, then efferent arteriole. So with the created pressure, you are pushing the blood, isn't it? You are pushing the blood. Then blood is also having some opposing osmotic pressure, we are saying. We created some pressure. Okay. So after creating some pressure, blood, we are trying to push the blood with that pressure. So blood is also some having some opposing pressure. Okay. So what is the opposing pressure here? 32 mm of Hg. Blood colloidal opposing osmotic pressure is 32 mm of Hg. Okay. Next, along with that we need to understand the Bowman's capsule. About the Bowman's capsule. So where does the materials are going to be filtered down here, isn't it? Here also some fluid is present. So the this is afferent arteriole and glomerulus efferent arteriole. I said blood is having some opposing pressure. Then fluid of Bowman's capsule is also having some opposing pressure. So how much opposing pressure will find? That nearly 18 mm of Hg is opposing osmotic pressure. Okay, opposing osmotic pressure. Let us try to show everything in one particular board. This is the Bowman's capsule and this is the fluid of Bowman's capsule. Let me draw the afferent arteriole, then glomerulus, which is entered here, that we are coming out through them, efferent arteriole. So what is 60 mm of Hg? The diameter difference between the afferent arteriole and efferent arteriole. The diameter difference between the afferent arteriole and efferent arteriole created pressure is 60 mm of Hg. Okay, with that we are trying to push the blade for filtration. Blood is also showing some opposing energy. That opposing pressure of blood colloidal opposing osmotic pressure is going to be 32 mm of Hg. Then we are trying to push that particular excretory wastes into the neck of the Bowman's capsule. So into the neck of Bowman's capsule. What is the opposing pressure there? 18 mm of Hg. Bowman's capsular opposing osmotic pressure is going to be 18 mm of Hg. Okay. So what is the created pressure? 60 mm of Hg. What is the opposing pressure here? 50 mm of Hg. The opposing pressure created here is the 50 mm of Hg. That means I am talking about the 32 mm of Hg and 18 mm of Hg. So collectively called 50 mm of Hg. Then what is the net pressure? Net pressure is going to be 10 mm of Hg. Net pressure is 10. With that net pressure, excretory materials are going to be filtered out. Excretory materials are going to be filtered out. So first of all, what I said, every object will have their own opposing pressure. If you are pushing someone, at least they show some the energy or not. On that way we are talked about. So that all calculations are there in front of us. That first of all, let us see the 60 mm of Hg. We need to prepare questions for this particular pressures. What is 60 mm of Hg? This is the answer, 60 mm of Hg. That what is 60 mm of Hg? How do you get answer for 60 mm? That what is the pressure created by the difference between the diameter difference between the afferent arteriole and efferent arteriole? That is about 60 mm of Hg. So that means the difference between the afferent arteriole and efferent arteriole creates the 60 mm of Hg osmotic pressure in the glomerulus. Okay. Then what is the pressure? The Bowman's capsule, that the blood in the glomerulus, the pressure created by opposing osmotic pressure of the blood glomerulus is 32 mm of Hg. Bowman's capsular opposing osmotic pressure is going to be 18. Then collective opposing pressure will be 15. We created 60. 60 minus 15, 10 mm of Hg. Okay, then I use the text language at present by writing all of these. That first of all, I'm writing 60 mm of Hg, then 32 mm of Hg, then 18 mm of Hg, 50 mm of Hg, then 10 mm of Hg. So I think we are getting late as a screen change. Okay, so 60, 32, 18, 50, 10. So for this, that's enough for today. That these are the topics to be learned over for that. So if we write, we are able to write that our question bank is having the straight questions like this. Search for that question. Don't go for other questions. Only search for these particular questions and answers. Okay. So what I'm saying here, that the diameter difference between the afferent arteriole and efferent arteriole, the pressure created, the diameter difference between the afferent arteriole and efferent arteriole is 60 mm of H. Okay. Then Bowman's capsular opposing osmotic pressure is going to be glomerular opposing osmotic pressure is going to be 32 mm of H. Bowman's capsular opposing osmotic pressure is going to be 18 mm of H. The total opposing pressure is 50 mm of Hg. So finally, the net pressure is 10 mm of Hg. So with that net pressure only, the excretory materials from the glomerulus, it will be filtered towards the neck of the Bowman's capsule. Then it is our responsibility to see that particular area, that the blood capillaries of glomerulus. The blood capillaries of glomerulus are composed of simple squamous epithelium. This area we are talking about, this area, the blood capillaries is having simple squamous epithelium. Then the Bowman's capsule, we know that Bowman's capsule is also composed of simple squamous epithelium. The Bowman's capsule is composed of simple squamous epithelium. So in the same way, that epithelium is having some basement membrane, isn't it? So this is filtration membrane. What is filtration membrane? If you remember, we used the same in case of alveoli. That alveoli blood capillaries are composed of simple squamous epithelium. The endothelium of blood capillaries are composed of simple squamous epithelium. The two simple squamous epithelium membranes are each other. The two simple squamous epithelial cells are going to be with basement membrane in between, that we said that the gaseous exchange, isn't it? In the same way, here also we are going to say that there is a basement membrane and the simple squamous epithelium of blood capillaries and the simple squamous epithelium of Bowman's capsule, which we consider this as filtration membrane. This is considered as filtration membrane. Okay, so let me write here, let me show that particular filtration membrane to you. So filtration membrane, we call this as filtration membrane. Okay, so then do we have any difference between the filtration membrane of the alveoli? As we said, both are composed of simple squamous epithelial cells and both are having basement membrane in the middle. Do we have any difference between the two? Yes, there is a difference. That endothelium of blood capillaries, of the blood is having some slit pores. Some slit pores are present. That means blood capillaries are having some small openings. We can say slit pores. And the simple squamous epithelium of Bowman's capsule You see, these are the cell membranes of the simple squamous epithelium of Bowman's capsule, isn't it? They are not like this actually. The simple squamous epithelial cells are having these particular finger-like projections. Finger-like projections. I'll show here. So that like this, the finger-like projections. Foot-like you look actually when you see separately like this. I'll show the different photographs of these after these, but let me write like this. So that leaving some between the two cell membranes, some gaps are coming, isn't it? So what do you say? Because of this only the simple squamous epithelial cells of the Bowman's capsule is considered as podocytes. Simple squamous epithelial cells of the Bowman's capsule is considered as podocytes. Okay, so if you see like this is the let me use red here. This is the blood capillary. As I said, blood capillary is having some minute pores, slit pores we say. Then similarly, our Bowman's capsule. Bowman's capsule is having, this is the simple squamous epithelial cells of Bowman's capsule. They are not like normal cell membranes. How they look like? They having like this, that podocytes, leg-like. That means you can see that foot-like structures that are leaving some small holes. So through the pores and through that particular openings, that filtration is going to be happen. So what we discussed till the time, this is glomerulus, that means blood capillary, and this is Bowman's capsule. So what is the requirement here? Filtration from the blood capillary to the neck of Bowman's capsule. For that, we discussed two issues till the time. What is that? One is pressure differences. That net pressure makes the filtration. So how does the filtration happen? That anatomical arrangement, that histological arrangement we are talking about. Through the slit pores of the blood capillaries, through that particular small finger-like openings of that particular the Bowman's capsule or podocyte, that is the filtration is going to be happen. Okay, that let me give the conclusion for today. This is the Bowman's capsule and the afferent arteriole. Afferent arteriole enter into the Bowman's capsule in the form of glomerulus. As we said about some diameter difference between the afferent and efferent arteriole. Because of the diameter difference, some pressure is created, that is 60 mm of Hg, and with that pressure we are trying to push the blade forward. That when you are pushing, the blade is also opposing some energy, that is 32, and with that pressure we are trying to push that particular wastes here into the neck of Bowman's capsule. They also show some opposing pressure. Here the opposing pressure is 18, that Bowman's capsular opposing pressure 32, the blood colloidal opposing osmotic pressure is 32, Bowman's capsular opposing osmotic pressure is, sorry, Bowman's blood colloidal opposing osmotic pressure is 32 mm of Hg, and Bowman's capsular opposing osmotic pressure is 18. That how much U are created between the due to the diameter difference, 60 mm of Hg. So created is 60, total opposing is 50, 60 minus 50, net pressure. With that net pressure, 10 mm of Hg is enough for the filtration of excretory wastes. The climax, finally, with the net 10 mm of Hg, all that excretory wastes are just dropped down into the neck of Bowman's capsule. So this is the very important portion. You may have small paragraph in the text here, but understanding that particular paragraph is going to be very, very important here. Then, okay, so we reached glomerular filtration is over. So what is glomerular filtration? From the blood capillaries into the neck of Bowman's capsule, materials are getting filtered out. Okay, very good. So what are they actually? What are they? They are actually, we say they are all excretory wastes, isn't it? They are all actually the excretory wastes. By and what way we filtered them? By feeling so they are excretory wastes. But when we create some pressure to send to push the particles of the blood into the neck of Bowman's capsule, that what is the rule that only excretory waste is to be filtered out, isn't it? Along with the excretory wastage, some useful substances are also fall down. Here, like glucose, vitamins, minerals, then water, along with the excretory wastes like ammonia, urea, uric acid, then some useful materials are also dropped down. Okay. So then in the next class, what we are going to do, that is very important for us, that filtering these materials into two directions. We have to give the two directions to these materials. In the earlier class also, I discussed on this particular area. So we are giving two direction. What is this? That means we are absorbing. This arrow mark shows we are absorbing. We are absorbing. So what is the path of this? As I said to you, that you need to remember always this particular. When the PCT, when the particular materials are absorbed into the proximal convoluted tubule and distal convoluted tubule, that what happens here? That will be collected by the peritubular net, renal venule, and that goes to the renal vein. Okay. Then when we leave, when we just pass the excretory wastes in this way, what happens here? They go into the, these particular excretory wastes are going to move into the urinary bladder. That's why I'm saying, going to say the coming day topic is very simple. They're very simple. What it explains? It explains either we absorb or either we leave. We may absorb or we may leave. Whom we absorb? Whom we absorb? In the glomerular filtrate, we say that after the filtration, this material has glomerular filtrate or primary urine. So we are separating the glomerular filtrate or primary urine. Some materials we absorb and some materials we absorb, some materials we leave. So whom we absorb, whom we leave, what are the techniques we are going to apply to absorb that particular materials, all the issues we are going to discuss in the next class. So the today's topic is just simply we say 60, 30 to 18, 50, 10 answers for the questions for these answers. If you remember, that first part of this urine formation is completed, like glomerular filtration. People feel so this is the complicated part. That this complicated part I just shown on one screen with number 60, 30 to 18 and 50, 10. So with I'm closing with this itself, the 60 mm of Ag. The diameter difference between the afferent arteriole and efferent arteriole creates some pressure in the glomerulus, that is 60 mm of Ag. 32 mm of Ag. Bowman's capsule, the blood colloidal opposing osmotic pressure is going to be 32 mm of Ag. 18 mm of Ag. What is 18 mm of Ag? That opposing osmotic pressure of the Bowman's capsular fluid. The fluid, Bowman's capsular fluid opposing osmotic pressure is 18 mm of Ag. 50, the total opposing pressure is going to be 50. Then net pressure that created is 60 and net pressure is 10 mm of Ag, isn't it? So with that net pressure, the filtration occurs. What do you say? Glomerular filtration. Added to this, we are seeing that anatomical arrangement, the histological arrangement also. Okay, we continue with urine formation, absorption and secretion process along the length of renal tubule will be discussed in the next class. Okay, thank you.